Very good morning, students. Welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Today, we are going to start a new chapter, Laws of Motion. And we are in the first session. So far, we completed 3 chapters. After completing the kinematics in the last, this is the 4th chapter, which is the continuation of the kinematics, which comes under a topic called dynamics. Already I told you, the total mechanics is classified into statics, kinematics, and dynamics. Statics is study about body at rest. So, you see statics. When body is at rest, study about the body at rest is called statics. Then kinematics, which already learned last class. Kinematics is when the body is in motion without considering the cause of motion. But whereas dynamics is study about the motion by considering the cause of motion. For every body to move, the cause is force. So when the various scientists, when they are studying about the motion of a body, Sir Isaac Newton, very anxious to know about what is the cause of motion. Why bodies are undergoing motion. In that anxiety, he discovered a new word called force. Right? Force is the cause of motion. The motion is the effect. So after knowing about the motion, he proposed 3 laws to explain about the entire process of motion, which are popularly known as Newton's laws of motion. So which completely explains about the motion of the body under the influence of force, which is studied under dynamics. In dynamics, one part is laws of motion. So we have to discuss about the 3 laws of motion with our day-to-day applications, so that we can understand what is the concept behind the laws of motion, right? So laws of motion is the continuation of the kinematics only. Kinematics we left at the equations of motion, and we have seen so many terms related to motion also. So welcome KTS Jogipet and Tejashwini. Then further study of the motion, out of anxiety, a word force is discovered by Sir Isaac Newton. So to undergoing explanation of the force, to explain the force in details, the Newton's proposed 3 important laws. They are all 3 together are called Newton's laws of motion. See, in this chapter we are discussing about first we start with what is force. Already you know very well. So first we discuss what is force, what are the different types of forces. Then Newton's first law, Newton's second law, then important word impulse, then Newton's third law, then conservation of momentum, and of course weight of the body and connected bodies. These are the different topics which we are going to discuss in the chapter Laws of Motion, which is the chapter number 4. It is page number 83. You can check. You're here, right? So we'll see. Now first we'll start with the basic of what is exactly the force, which is responsible for the Newton's laws, right? So when there is no force, there won't be any Newton's laws. Okay. Force, as word is introduced, Newton's proposed the laws. So force may be either pull or push. Right? Pull or push are technically termed as force. Got it or not? Either pull or push. For example, you are sitting on dining table. There are so many dishes are there in front of you. So you've taken the plate. So either you have to pull the dishes towards you, or somebody should push it. Otherwise, you cannot get that items into your plate, or it won't go to your mouth. Correct or not? We need to apply some muscular force. A muscular force to pull it or push it. Suppose when you go to any mall or any cinema, cine theater, or in your offices or your school also, when you want to open the door or when you want to close the door, what you have to do? Either you have to push the door or you have to pull the door. Correct? Either pushing or pulling is a type of force only. A kind of force to either to push or pull, which changes the position of the, what happens when you are pushing or pulling? The body position changes or try to changes. Such term is physical quantity is called force. Either push or pull, which changes the position of the body, is technically known as a force, which is introduced by Sir Isaac Newton. Right? Correct or not? So when you come to the force part, so as it is push or pull, so it may be there are two types. When you see the types of forces, even there are so many varieties are there, but they are classified into either contact force or non-contact force. What? There are two types of forces. The force exerted, see, the force to be applied, there should be at least two bodies. That is very important condition. At least there should be two bodies to exert the force. Out of these two bodies, they may exert the two forces, maybe either by contact or by non-contact also. When you are pulling a door or pushing a table, so you need to apply your muscular force. That is contact force. We cannot move any body by magic. Right? But when you are dropping a body, suppose I'm dropping a pen. Because of the gravitational force, even though there is no direct contact between my pen and earth, because of the gravitational force, what happening here? Because of the gravitational pull of the earth, the body is coming. That is non-contact force. Contact force are muscular force, frictional force, normal force, and mode force are there. Whereas non-contact force are gravitational force, magnetic force. See, magnet also, place some iron somewhere and magnet near. Iron and magnet will attract. Even though there is no direct contact, there is a force comes into play. They are called non-contact. So force may be either contact force or it may be non-contact force, which makes the body to move. Right? Then what is force will do? So what is the effect of force? Very important again. Right? Third one is effect. So force can change the shape of the body. If you apply the force, you can make the duff into chapati. How that you are giving shape to the chapati? Because of the force only. Means it can change the shape. For example, when you are pumping the air into the tire, so tire will bulge. Shape of the tire is changing because of the force, air force. So it can change the shape, it can change the size, it can change the direction. When you apply the force only, you can change the direction by a vehicle. It can change the speed. It can increase the speed, it can decrease the speed. With the application of force, we can increase the speed. When you accelerate, force increases. When you apply the brakes, force decreases. All these are the effects of force. Means force has a lot of effects. It can change the size. It can change the shape. It can change the direction. It can change the speed. Either it can increase the speed or decrease the speed. Clear? So this is complete about the force. So there are various types of force are there. Out of contact and non-contact, many types of forces you can see in our day-to-day life. For example, first commonly used is our muscular force. Muscular, muscles, force of muscles. Then magnetic force. So many you can write. Then electric force. Right. Then frictional force. So nature's force. Right. Then comes normal force. Then comes spring force. So many are there. Keep on. Then nuclear force. All these are the different types of forces. They may come either into the category of contact or in category of non-contact, mostly gravitational. Again, gravitational force. Force of Earth. Again, discovered by the Newton only, by sitting under apple tree. Right. So before entering into the laws of motion, the reason to propose the laws of motion is force. What is the need for the Newton to propose the laws of motion? Is just because of the force only. Because he is very anxious to know about the reason behind the motion. When all the scientists are studying about the motion and the types of motions, he changes he deviated and want to find out the reason. Then he found that there should be either pull or push, either directly or indirectly, which makes the body to change the position is called force. It may be either contact force or maybe non-contact force, which can change the shape of the body, size of the body, speed of the body, direction of the body. So based on this, she proposed the complete laws of motion, total laws of motion. Clear? So now we are clear about the what is exactly the forces. What are the various types of forces we can see, right? So unit, when you see the units of force here, after knowing about the force and effects of force, just you find again what are the units. Force is measured commonly in Newton. Newton is the unit named after scientist, or even CGS system, it is dyne. MKS, Newton, CGS, dyne. Right? Or even sometimes they measure in kgf, kilogram force also, kgf, which is nothing but 9.8 Newton. Okay? Clear? So later we can come again, SI unit and CGS, MKS units of these are given. So force completely. Again, these forces are, some forces are there like balanced forces, unbalanced forces. When you see here, there is a pictures are given. A game, tug of war, you can know. A game called tug of war, pulling the rope. The forces are balanced. Suppose see, 300 Newton, 300 Newton, both. Then nowhere it is moves. Whereas this is 400 and 300. So it moves in the direction where there is more force is applied. Right? So when the two forces acting in the opposite direction, equal forces acting in opposite direction, they are called balanced forces. If unequal forces acting on opposite direction, they are called unbalanced forces. See, picture clearly indicates when three persons, they are applying the force of 300 newtons one side, 300 newton other side. Then it won't be moved any side. There is no winner. Match is draw. But in second case, you can see there, the left side is moving with the 400 Newton. Right side, 3 people to 300 only. So definitely the game will move towards the 400 Newtons, which is called unbalanced force. So force can be either balanced or unbalanced. When force can be balanced, the body is at rest. When force is unbalanced, body in motion. Either moves towards right or left, or up or down. Right? Clear? This complete picture about the what is force. Okay. So some more examples. So many examples of force are given. Right. See, types of forces. I told contact force or non-contact force, also called field force. A force exerted by object on other object only when they are in contact is called contact force. Example 3. That is, this is called frictional force. Push or pull. Normal force, I told. Normal. The word is missing. And fluid force. Force of the liquid. Right? That is non-contact force. So, without being in contact, we can say applies field force on the other. See, when block is placed on one block on one other. So, what happened? Weight of the body acts in downward direction. Whereas, the same force acts in upward direction is called normal force. Every body, when they are in contact, the normal force comes into play, or frictional force comes into play. Right? These are the various types of forces: normal force, frictional force, applied force, or muscular force. So these all are the one of them are the reason for the, see, some more are given. Gravitational pull. Whenever a body is either coming towards the earth or moving away from the earth, they are pulled towards the earth, which are called gravitational force. So magnetic force and electrostatic force, which are comes under all these three are comes under the non-contact forces. The force of poles of magnet are called magnetic force. Force of charges are called electrostatic force. Force of earth are called gravitational force. All these three are comes under non-contact force. What is non-contact force? So this is complete picture about the force before starting the Newton's first law. So after knowing complete picture about the force, we have to move to the exactly what is the Newton's laws, right? So before that, before going for the Newton's first law, let me show you one video on the force and Newton's laws. First, watch the video very carefully, which is helpful for you. Then we'll move to the next part, right?
Every time we move something, how many times you would lose your papers if inertia didn't make it stay where you put it? Using force. Think about how many times use our pencil or walk, we are using force. Think about how many times you would lose your papers if inertia didn't make it stay where you put it. Objectives. At the end of this lesson, you'll be able to define force, distinguish between balanced and unbalanced force,
see clearly,
Newton's law of motion, relation between force and the state of motion attained by it, understand the conservation of momentum. Force and its types. The object will undergo change in its direction, speed, or shape only if force acts on it. Hence, force is defined as: force is any influence that causes an object to undergo a change in speed, a change in direction, or a change in shape.
Right, that is effect.
Need your English proficiency test score before your college application deadline? Get it done with the Duolingo English.
Force is a vector quantity. Force is of two types: balanced and unbalanced. Balanced force means two forces are acting on opposite sides of the body, and that body does not change its position. Example: a block pushed from both the sides with equal force. Unbalanced force is one that is not opposed by an equal and opposite force to cause a change in the object's position. Example: when block with great force on one side. Newton's first law of motion.
Now, first to see this, then we can explain.
The book will not move by itself. It will change its state of rest only when force of hand acts on it. This explains us the first law of motion. First law of motion states that a body will remain at rest and a body will remain in motion until and unless external force acts on it.
Simple concept this is.
Application of Newton's first law of motion.
Where it is applicable in our day-to-day life.
When a bus starts suddenly, the passengers fall backward because of inertia. The passenger tends to remain in the state of rest even if the bus has started moving. Inertia is the property of the body due to which it resists the change in its state of rest or of uniform motion. Mass is the measure of the inertia of a body. Larger the mass, greater is the inertia. Example: when the car stops suddenly, the driver is jerked forward because of inertia. The passenger tends to remain in state of motion even if the bus has stopped moving.
Right. You can read from the screen also.
Newton's second law of motion.
See this completely so that you can
Newton's
understand.
second law of motion states that the force acting on the body is directly proportional to the mass of the body and acceleration produced in the body in the direction of the force applied. F is equal to m into A,
Famous law.
where F is equal to force, m is equal to mass, A is equal to acceleration. Units of force.
Yeah, see.
The SI unit of force is Newton. Newton is defined as the force acting on the body of mass 1 kg, producing an acceleration of 1 meter per second square. Unit is equal to kilogram meter per second square, or Newton. To calculate force of body having mass 1000 kg
F is
and
going to be a
acceleration of 0.5 meter per second square, then F is equal to 1000 into 0.5, which is equal to 500 Newton or kilogram meter per second square. Application of Newton's second law of motion.
Where it is applicable.
Cricket player lowers his hands along with the ball to catch it because the acceleration of the ball gets reduced and hence overall smaller force is applied to stop the ball and no injury is caused to the hands of the player.
Right. We take the hand backside. Change
Momentum.
the time so that force will decrease.
Momentum is mass in motion. P is equal to
Mass into
m
mass.
into v, where P is equal to momentum, mass is equal to mass of the body, v is equal to velocity of the body. SI unit is kilogram meters per second. Hence, combined effect of mass and velocity is called momentum. It is a vector quantity. The change of momentum of an object is proportional to the applied unbalanced force in direction of force.
It is the second last statement.
Formulation of second law of motion. The change of momentum of an object is proportional to the applied unbalanced force in direction of force. Let the initial momentum be P1, which is equal to mu.
All expressions
Let the
come later.
final momentum
Just
be
I'm showing the video
P2,
so that
which
you
equals
can remember and
mv.
understand the explanation easily.
The change in momentum is P2 minus P1, which equals mv minus mu. Rate of change of momentum is m into v minus u whole upon t. Force is equal to k into m into v minus u whole upon t. Force is equal to kma, where k is the proportionality constant.
It's complete derivation for the second law of Newton. If it's called MA. Right. Now little bit is there. You can complete.
Newton's third law of
Most
motion.
important drawing the Newton.
Whenever one body exerts a force on another body, the second body exerts an equal and opposite force on the first body.
For every action,
Every
there is
action
equal
has
opposite action.
equal and opposite reaction.
Right? This is a commonly observed law.
Examples to illustrate Newton's third law of motion.
So many you can see.
How do we walk? When we walk on the ground, our foot pushes the ground backward, and in return, the ground pushes our foot forward.
Yes. Action, reaction.
Why the cannon recoil?
Bullet will go forward and go
When ball is
back.
fired from a cannon, the force sends the ball forward and is equal to the force sending the cannon backward, hence the cannon is said to be recoiled.
Recoil of cannon,
Jet aeroplanes and rockets.
satellites, everything.
The action of the gases downwards of the rocket
Okay,
gives
so-
equal and opposite reaction to the rocket to move upward with great speed. The case of hose pipe. The fireman directs a powerful stream of water. They hold it tightly because it has tendency to go backward due to the backward reaction of water rushing in forward direction. Law of conservation of momentum.
So
When
final-
two or
all
more
the-
bodies act
all
upon
these
each
are there in
other,
your textbook as
their
it is.
total momentum remains constant when no external force exerts on it, is called law of conservation of momentum. Momentum is never created or destroyed. It is also called principle of conservation of momentum. Let two objects of mass ma and mb traveling in the same direction have initial velocities as ua and ub respectively, and their final velocities be
EAV.
va and vb respectively. The rate of change of momentum of ball A be FAB, which is equal to MA into VA minus UA upon T. The rate of change of momentum of ball B FBA is equal to MB into VB minus UB upon T. According to the third law of motion, every action has equal and opposite reaction. Hence, the force exerted when both objects get coiled is FAB is equal to minus FBA. On solving, we have MAUA plus MBUB is equal to MAVA plus MBVB, where MAUA plus MBUB is the total momentum before collision and MAVA plus MBVB is the total momentum after collision. The sum of the momenta of the two objects before collision is equal to the sum of the momenta after the collision when no external unbalanced force acts on it. Momenta is the plural form of momentum.
Right, this is the completely called law of conservation of momentum, which is the last topic in our lesson. So just go through the video repeatedly in the recorded video so that you can understand the further concepts clearly that I am explaining, right? So now we are in the first law only, but we have discussed about second and third law also.
Hello, hi, welcome to my
Video.
channel.
Okay.
This is me, Vitika. Again, I'm back with
Right.
your most favorite DIY. No. Actually, it's
Just
Did you know Sir Isaac Newton sought to describe the motion of all objects using the concepts of inertia and force, and in doing so, he found that they obey certain conservation laws. Equilibrium occurs when the resultant force acting on a point particle is zero. In systems where
Then an
objects are
observation
moving
made by
with
the
different velocities, it is impossible to determine which object is in motion and which object is at rest. In other words, to phrase matters more technically, the laws of physics are the same in every inertial frame of reference, that is, in all frames related by a Galilean transformation. Weightlessness when in free-fall orbit around the Earth and Newton's law of motion are more easily discernible in such environments.
okay. So this is our complete picture about the given by the Newton. Okay.
Summary.
So that is about total summary about the all the Newton's laws of motion chapter, right? So we have seen the entire video, which is completely related to Newton's laws of motion. So that video explains you about what is force, which already we discussed. What are the various types of forces? What are the contact force, non-contact force, and what are the balanced force, unbalanced forces? Then explain about what is the Newton's first law importance and applications in our day-to-day life. What is Newton's second law and what are the applications and the equation F is equal to ma. Then enter to the very important Newton's third law, that is action is equal to reaction or minus reaction, and the examples of Newton's third law. And final conclusion summary of the total video is mentioned. So that is very helpful for you to understand the concept easily when I'm explaining, right? Now we can come to the, before closing the session, let us see about the Newton's first law of motion. Right, this is Newton's first law. So very simple concept. Suppose your cycle is kept in your school with stand. You stand your cycle and kept it. Until unless you move that one, you apply the force on it, it won't move there. It will be in the cycle stand only. Similarly, when a book is placed on table, it never move. It never move until unless force is applied. Such property of a body to not change its position by itself is called inertia. So Newton's first law introduced a new word called inertia. That's why Newton's first law is also known as law of inertia. So what is the inertia? It is the internal property of a body. Suppose I am sitting here. I cannot move from chair until unless I apply some force. To apply some force, I can move to some place. Simply if I sitting, I cannot move. Correct or not? Because of the inertia. Such property is called inertia. An inherent internal property of the body by which body cannot change its position until an external force is applied. Body may be moving uniform speed. Suppose you are going by vehicle, you are going with a constant speed. Until you apply the force on accelerator or brake, you cannot change your speed. It will be uniform only. Suppose you are at rest. Until you apply the force, you cannot move from rest to motion. Correct or not? So force plays vital role in changing the position of a body. That is explained clearly in the Newton's first law. So what Newton's first law says that here, you can see. A body at rest will remain at the rest, and bodies in motion remains in uniform motion unless it is compelled by an external force. Compelled means forced to change its state of rest or uniform motion. So Newton's first law is also called Galileo law of inertia or law of inertia. So what is inertia is given here. Inertia is the body may be defined as the tendency of the body to oppose the change in its state of rest or uniform motion. Means it cannot change its position. It resists, it opposes the change of position until an external force is applied. Right? Until external force is applied, no body will change. So either it may be change of rest to motion, or motion to rest, or it may be change of direction. Simple, I'll give one example for all the three. Suppose you sat on a bus. Bus is at rest. Right? Bus is at rest. You are sitting in bus. Means you are also on rest only. Driver came and started the bus suddenly. When bus is started suddenly, you will feel jerk backside. Why you are jerking only upper part? Because lower part is comfortably sat on the seat. But upper part, it is at rest along with the bus. But when you are moving from rest to motion, body is not supporting because of the inertia. So you feel jerk. Similarly, when the bus is going with good speed and stopped suddenly, so you fall forward. That is also because of the inertia of motion. So when you are turning the bus or turning any vehicle, what you have to do? You have to bend it. If you want to bend, what happens? You'll fall. So whether the bus is turning towards left side or right side, will bend like this. Why bending? Because of inertia of direction. Suppose in cricket, if you see, a bowler is bowling a bowling. So he won't bowl directly from the wicket only or from umpire. He will run some distance because he want to make his rest body to take it to the motion by running for some distance. Then he can bowl with a great speed. That is because of inertia. Suppose when you are running bus, a bus is running, you want to get down. After getting down on the bus, you have to run for some distance. We cannot stop immediately. After jumping, if you stop there, you'll fall. Because you are in the motion along with the bus. To come to rest, you need to apply some force by running. So many examples are there for the Newton's first law. Right? Clear, all of you? So this is completely about Newton's first law. It is also called law of inertia, inertia at rest, inertia of motion, and inertia of direction. 3 types of inertias. Right? So in next class, when you meet in the tomorrow class, we'll discuss about the Newton's second law and Newton's third law. And momentum, impulse, some more important points are there. Okay. So today we'll discuss clearly about what is force, what are the types of forces, and what is the Newton's first law of motion with various examples. So many are the examples. Everywhere in our day-to-day life, we can observe that unless a force is applied, we cannot change the position of a body. Either a body may be at rest or body may be in motion. Everything needs force. Okay. Now, this is the homework for today. Explain Newton's first law of motion. Right. So note on the homework and write the homework in your notebook along with some important points, synopsis from your material. Right. So thank you very much. That's all for today. Have a wonderful day. Thank you, friends.